Okay. Okay. Good morning, all. I, Professor Deepak Pandita, welcome you all for the webinar on web application architecture. So, on behalf of PCET's Pimpri Chinchwad University, I would like to uh, thank Mr. Amit Jadhav for sparing his valuable time. So, on behalf of PCET Pimpri Chinchwad University, today we are going to conduct a webinar on web architecture, web application architecture. So, the webinar would be conducted by Mr. Amit Jadhav, who is currently working as a software architect at ZS Associates in Kharadi. Amit Jadhav has more than 7 years of experience in IT, which includes IT various domains like Microsoft Azure, web services, and currently he is working with ZS Associates as a software architect. So, without further ado, before starting the webinar, I would just give a brief view about our university, which we have started in 2023. Okay. So, just I will share the screen of the glimpses of the university. Just give me 1 minute.
Of academic, the Pimpri Chinchwad Education Trust has established a state private university known as Pimpri Chinchwad University at Sate, Vadgaon Mawar in Pune Metropolitan Regional Development Authority. It is a 30-acre campus of academic facilities and amenities for students and teachers to help them to achieve their fullest potential. The Pimpri Chinchwad University campus is well connected with the cities Pune and Pimpri Chinchwad by road through Mumbai-Pune National Highway number 4 as well as Mumbai-Pune Expressway. Also, railway station Kanhe is at 1 kilometer distance. The nearest airport is Pune Airport. PCU has its different verticals which prepares leaders from different fields. School of Engineering and Technology. School of Design. School of Media Arts and Communication Studies by incorporating cultural activities, events, and organized tours and trips, fostering a holistic development approach. In a sense, Pimpri Chinchwad University is not just an institution. It is a vibrant ecosystem that nurtures talent, fosters creativity, and provides a platform for students to thrive in every aspect of their academic journey. PCU Bus Transport provides service across the city. Pimpri Chinchwad University, transformative education that empowers success in a rapidly evolving world.
So, Amit sir, this was a short glimpses of the university. Okay, so without further ado, I would like to request Amit sir that you can continue with the session, sir.
Thank you, sir. Share my screen.
Yeah, it is visible.
Okay, so today we'll be covering the web architect application architecture, how the different components are there in a web application, how they interact uh, with different layers and components. Uh, we'll overview how when we use any web application, how internally it works, what all things at backend happens. Uh, I'll be focusing on that part in today's session. So mainly the agenda is to cover these points listed on the screen. First of all, the overview of web application architecture, then the components involved in an web application, the different components which are there. Then we have a sample high level architecture where we'll be displaying the components, different components, and then we'll be doing looking into the technologies used to develop a web application, high level what all technologies framework are available in the market and what currently industries are using, and we'll deep dive into one of the web application architecture at low level where we are defining or listing all the services used uh, behind the scenes and how they interact with each other and how a web application actually works when deployed. And then we also have a topic where we might be hearing in future different types of scaling, and we'll be covering what are the different types of scaling and how that happens. So there are multiple types of scaling, and then at last we'll be displaying the technological stack for a full stack developer or for a full stack web application development. What is the technical stack which is used in the current market? Do pause. Do let me know in between if you have any questions. Feel free to go on, unmute yourself and ask the questions. So, overview of web application architecture is what is an web application architecture? So, architecture is nothing but the blueprint of how different components of a web application interacts with each other and communicate with each other. So it is a type of protocol for exchanging data over the web between a database and a browser. There are different types of web application architecture which we'll be covering in upcoming slides. If I list them, there are mainly three. One is monolithic, then we have microservices, and the third one is serverless. So I'll be covering all these three in future slides. So when I talk about the component, when you access any of the sites, what all things are there, what all things build up a website. Example, when you access Google, when you access Facebook, when you access any of the website which you are using, it is basically divided into three components. The web browser itself, where you actually open your URL and you interact with the website. Then there is a web server who is responsible for transferring the data and processing your request. That is when you're hitting a website, the request is handled by a server and a page which you're viewing is written by the server and which is rendered by the browser. So what I mean by rendering is The browser reads that data, converts that into some GUI. GUI is a graphic user interface where we have some text fields, buttons, and other stuff like images, videos, and whatnot. Then we have a data server where we store all the data, which is which we are viewing on the screen. So there are few manipulations which happen at the web server. After doing that manipulations, we store that data where a database comes into picture. So we'll be showing what all things are there in each component. This is a basic three-tier web application architecture altogether, which ideally all the web applications uses. The first one is client side, second is front end, and third is back end. So again, client side can be any browser which we are using, or a web application or a mobile application that are called a client side component or architecture. First tier, we can say it. So it can be a Google Chrome, Microsoft application, or any Google application, or your any browser, or any of your app which you have in your mobile, tablet, and other stuff. So front end is mostly the presentation layer where user interacts with the web application. So again, front end, you have a mobile application, a browser where you present your website, and that is called a website which is listing on your browser is called a presentation layer and a front end. At backend is the heart of your web application where all your business logic is happening. Like if I say if we check the bank transaction server, if you are using phone pay, Google Pay, you might be doing some scan and you might be paying some amount. So you only have GUI to scan it. That is your application is your front end. Backend is where you scan and you just enter your amount and enter your password. Backend is the main thing where all your transactions are happening, where your amount is getting deducted from your bank account, and then that amount is getting transferred to the receiver's bank account. So this is where our business logic is written by some developers at backend, which is getting executed, at the end of which your transaction is getting completed or failed based on the business logic which is written. And how we store and keep the historical data as well as current data, that is your current bank balance, your current transaction details, your past bank statements, that resides in the database layer. So database layer is used mostly to store your data in different types, that is a relational or non-relational, that is SQL or NoSQL database. There are different kind of database which will be listing in our next slide. But database layer is the layer where the data resides, and using business layer, we access that data and display it to the front end presentation layer on your web application browser or any of your installed application. I will take a quick pause and check if anyone has any questions on this. Okay, I'll take it as a no. Do let me know if the speed is okay or it's too fast, or if it needs to be slowed down. Okay. So to develop a web application, there are different technologies present in the market, but the one which are listing on the screen are widely used by most of the web applications, by most of the industries experts in the current market. So the list at the right side is the languages which are used to develop the presentation layer. That is HTML, CSS, and JavaScript. These are the basic languages which are used. Can you sing anything? Okay. So HTML, CSS, and JavaScript are the languages which are used to develop your presentation layer, your screen which is visible in your web browser, and These languages are used within the technologies, that is Angular, React, Vue.js. These are different kind of technologies frameworks which are used to develop the presentation layer. So all the presentation layer are mostly, you can see, will be able to find HTML, CSS, and JavaScript. These are the basic things to develop any web application page which you view in the browser. Then comes into the picture the backend technology, which is the heart of your web application. So again, the backend technology consists can be developed in using various technologies. Few of them are listed on your screen. That is Node.js, Java, Python, PHP, Go, Ruby, .NET. So these are the mostly used backend technology in the current industry to develop your backend of any web application. Again, each of the language technologies listed on the screen has their own framework to develop a web application. And what I mean by framework is nothing but collection of functionalities tied into a single library. So it is some kind of library which you will be using, which are readily available, developed for you using some of the technologies on screen, which you can use and start developing your application instead of mainly focusing on your boilerplate code or low level code. So that is handled by some of the framework. So just to list down few of the frameworks, as in Java has Spring Boot as the widely used framework. Python has couple of framework, that is Django and Flask, widely used. Yeah. So these are mostly the two frameworks which Java and Python has. Each technology has its own framework, which you will be using to develop any of your web applications backend. Then comes into the picture the database technologies, where actually your data resides and you query the data and fetch the actual data. So again, the database are segregated into two databases, that is relational and non-relational. So relational data types databases are MySQL, Postgres, SQL Server, Oracle. These are the relational database where you have one to many foreign key references in your table. Then for non-relational database, you have MongoDB, Cassandra, few other databases as well, which in which you don't have any relation between your databases. So based on your requirement, your architecture, and the presentation layer which you are developing on your application, you decide one of the technology, database technology listed on the screen, and start developing your application. So widely used NoSQL databases are MySQL database and Postgres, which is heavily used in small to medium scale application. And when you come in, when you consider the large scale applications, Oracle, SQL Server are widely used in the large scale applications. And where you don't have relation, MongoDB is the one from the no relation database. Then comes into picture some cloud services and cloud providers. So what are the cloud providers? That, yes, Mansi. Okay. So what is the use of cloud providers? We'll deep dive into low level when we are deep diving into low level architecture of this uh, web application. That time we'll be looking what cloud services helps in. But these are the widely used cloud service provider in the industry. That is AWS, Amazon Web Services, Azure, Microsoft Azure, and Google Cloud. These are the three cloud service provider which are heavily used. At high level, these cloud service providers are used to deploy your application. That is, once you are done with the development and you want to host it so that someone can access it using their browser on their application over the web, you deploy this application in some of the cloud services. And these are the widely used cloud services which I have listed on the screen. So mostly in the upcoming examples, I will be focusing on AWS cloud services, like how which all services are used in the architecture to deploy or serve your web application. Then we have gone through all the components which are present in an web application. That is a presentation layer, a backend layer, and a database layer. So at high level, it's called a front end layer, backend layer, and database layer. These three layers till now we have a deep dive into these layers, but how they interact with each other, like how front end uh, communicate with backend, and how backend communicate with the database. So to communicate between different modules, different layers of your application, API comes into picture. So what is an API? API is an application programming interface which is used to communicate data between front end and back end using uh, different types of protocol. The widely used protocol are SOAP and REST. Again, REST is at the top as of now since it is more flexible and it supports multiple types of format for data exchange. So if I wanted to give you an example of API, let's consider Uber or Ola application which you use for booking a cab. So you have a Uber app, you open a Uber app, you navigate into a map, you enter your location. But the location or map which you view in the Uber app is developed by Google. So ideally Uber uses Google Map, but how Uber is able to use Google services? The reason Uber is able to use Google services is because Google has exposed their APIs to Uber, which Uber is consuming in their front end and showing you the maps, that is the data. So Google is sending their data via API, which is read by Uber app and rendered on the UI to view the map inside Uber app. So over here, API comes into picture. Then again, the previous example, bank example, which we took, a UPI app, Google GPay app, where you send the data. There are different kind of bank involved in that transaction. So how different kind of banks communicate with the GPay or PhonePe or any other UPI app that is using an API. So they have exposed their API, a contract. So mainly a API is nothing but a contract to which backend services export their data structure, and the front end consumes that data structure, or the user. Mostly the consumer of API is not always a front end, it can be a back end, different kind of back end services communicating with each other, like two different banks in an GPay transaction or Google Pay transaction, while doing a UPI payment, communicating with each other, that is senders bank and receivers bank. They communicate with each other at back end using the APIs. So SOAP is a simple object access protocol which is used to transfer data via API, and it is a highly structured and only uses XML format, due to which nowadays it is not widely used, because mainly nowadays most of the technology supports different kind of data exchange, that is XML, JSON, that can be a file structure, and other data type as well. So that's the reason widely we use REST APIs nowadays. The reason is that it is flexible and it supports multiple formats. XML is nothing but an extensible markup language, which is used for transferring the data. And JSON is simple data structure. You can data type or data API programming type, which is used to transfer your data. Again, before starting or deep diving into the low level details around the web architecture. I'll take a quick pause and check if anyone is having any questions around the topic which we covered.
Amit, one student had a question.
Yeah.
Can I just
Yes, sir.
let you know?
Go ahead.
So, how the categorization of this architectures is being done means three-tier, then for entire architecture. So, what are the various layers that are added?
So mainly, most of the web application you will find it is a three-tier, that is front end, back end, and database. And where when the tier increases, the technology which is there, that is a data science comes into a picture, where the data warehouse, data analytics comes into a picture. Then this comes to a four-tier architecture. So mainly, all of the web applications are three-tier or one tier, not two tier. And the reason it's one tier is if you go on Google and search some blocks, so their blocks is statically written. So they don't have any processing, any data input or data output. That are the static places. So that's the reason they only have a presentation layer, no business logic layer or database layer. So that is the one tier architecture. Three tier is where your business logic comes into a picture, and four tier, five tier, again based on your technological stack which you try adding into your web application. That is a data warehouse where again data scientists work on your data warehouse to create BI analytics, data analytics, and different kind of reports.
Thank you.
In this example, we'll be focusing on three-tier architecture since this is the widely used architecture, and the four-tier and five-tier are mostly abstract layer, which is not considered as an tier in the industry as such, because altogether it's a separate functionality which is executing at backend, which does not have any impact on your web application, and that's the reason it is an abstract layer for your web application, the data warehouse and other stuff. So I'll be covering that in this low-level architecture. So whenever you're opening any website, web application, what all things happen in the back? What all technologies comes into picture? How your request is processed? That is listed on this in this diagram. You can have a look into it. Whenever I am opening, let's say google.com on a browser, I am hitting a website on my browser. I'm opening a browser. I'm hitting my website on the browser using web browser. Then the web browser sends the request to DNS, and this DNS again have some mapping with the load balancer. DNS is nothing but a domain name server. So this is used to map your servers to a domain, that is www.google.com. So this is a domain where our application is mapped, and that is mapped using a DNS. So DNS transfer, like DNS looks into it address list, checks where this uh, google.com request needs to be navigated. Based on that address, it navigates the request to a load balancer. Load balancer is nothing but an API gateway. And what I mean by API gateway is nothing but uh, a layer where your request comes in and out from. Like it is a gateway where all your requests are served from, and which is visible to the public, which is publicly hosted. So that again, the load balancer or a gateway have a mapping to web servers where your application is deployed, and that back servers can be categorized as a backend, front end, or a single server or a microservices, different kind of microservices. So in the current example, we have different kind of servers, that is front end server and a back end server, which is having serving this request. So load balancer checks the mapping into your request and navigate the request to a specific VM or web server. So web servers, again, if that web server needs some rendering or some business logic processing or some data, then that web server sends the request to backend server, that is API server, that can be a VM1, VM2, and n we can have n number of VMs. Then that VM just mouse stopped working. I'll just get back to that screen. Yeah. So this front end request navigates the request to backend service to get some data to business process some business logic, like the transactions which we said around banking server, that is to deduct the amount from the sender's bank and debit the amount, credit the amount to the receiver's bank. So that thing happens at the backend, and that backend data is transferred to the database. So similarly, when you're hitting google.com, Google sends that request to the API server, app server, that is backend server. App server gets the data from the database and then returns the request to app server again, and that app server request returns the request to front end server, and then front end server again sends the request to load balancer DNS, and that is rendered on your user browser. So this is how one request, whenever you're doing any of the requests on uh, around the web application on your browser or any of the app which you are using in your mobile, this kind of architectures comes into a picture. Then front end, based on like, there can be different type of use cases scenarios where other technologies comes into a picture. Like I said, if you are viewing a blocks only screen or a website where only blocks are present, where you only can read some of the blocks but there is no business logic processing in that website, so at that time front end sends the request to a cloud storage. Mostly this type of pages are stored on the cloud storage that are again read by the front end, or if it is cached, then it is read by the CDN, that is content delivery network, and that is transferred to the user browser. So CDN is nothing but the content delivery service which is used to cache your uh, static pages or static content. So then we have some other services as well in our architecture based on the use cases. If you have heavy database, heavy uh, usage of data where you have historical data, at that time your data warehouse comes into a picture. Your databases uh, can load millions of data, but if that goes beyond millions, that is in trillions, then the database becomes slow in performance. And when this type of cases comes into picture, we mostly transfer that data to some cloud storages or some data warehouse pipelines. So if you transfer that based on your architecture, if you're transferring that data into the cloud storages, then to perform some analytics, to create some reports, to extract some metadata out of it, there is a ETL process done on the warehouse, and to load the data into the warehouse, there are few pipelines set up where the data is extracted from cloud storage into some physical storage. On that physical storage, data warehouse is executed, and based on your requirement, if it is a BI analytics, it a data analytics, or if it's reporting, the framework or the technology which you're using works on the data warehouse and extracts the metadata. Then we have notification API, push API, services API. So this is some kind of APIs. Like if you're using WhatsApp, even though if your internet is disabled, and if someone sends you a message, and whenever you enable your internet, you get that notification that you have received some message. So how that notification works is using some notification services or push notification services which are present on cloud. So whenever someone sends you any messages, that messages is pushed to a notification service. that can be a different type of service. If I list that service in AWS, it is mostly SNS, simple notification service, which is used in the AWS. So where the notification is pushed and that resides into that service. And whenever you start your internet on your mobile, your WhatsApp goes and checks into that notification service if any notifications are there for your user. And if there is anything in the pipeline, that is sent to your mobile device and you get that notification. So a kind of queue is maintained in this notification service where all your messages are queued on the cloud. So this is a low level web application architecture which works on like most of the applications which we use. Any questions around any of the components? Okay. So do keep this picture in your mind. At least the front end, load balancer or API gateway, DNS, and user browser. These are the widely used questions or under like whenever you're trying to understand a web application, you will need to understand these things. That is how the request comes, like flows from a user browser to a database and back to user browser. At least this flow you should be aware of, you should be knowing whenever you're working in any of the web application related stuff, be it application development, application testing, or uh, uh, or if you're working as a program manager as well, you should be aware of this kind of flows. What all flows are there when you're developing a program? And and the technology which we listed, like front end, again the Angular or React JS comes into picture. Back end can be a PHP or Java or Python or Ruby or any other technology. And this database is nothing but a SQL or NoSQL, which we listed in our previous slides. That can be a MySQL or a Postgres or SQL Server or Oracle. But not there can be a case where different kind of database are used in mix and matches. So we have different kind of uh, types of web application architectures. So what I mean by that, the previous architecture which we saw, uh, I'll navigate back to that screen. So over here, you saw the architecture, how the web application architecture looks like. But in front end and back end, there can be a different kind types of architecture used to serve your application. So the first one is a monolithic app where all your components of a web application are interconnected and stored, assembled and deployed together in a single unit. So this kind of application is developed as a single module, single application, and deployed as a single application. So if I give an example of this, any of the projects, I'm not sure, but most of the projects which we create for a college purpose are a monolithic application where we have only a single project and we have all the classes or functionalities listed into a single application, and we host or execute that single application. That is an example of monolithic application. Then comes into picture microservice architecture. Microservice architecture is nothing but splitting your components into different projects or smaller projects as an independent component on the basis of business functionalities, where you can deploy your single application as a single server or single component as a single server, and group of components together forms an application. So this is a microservice architecture. Again, monolithic are the traditional one which previously most of the industries were using, But nowadays, mostly applications are developed as a microservice or serverless architectures. And then what is a serverless architecture is? Uh, it's again a kind of microservice where you have an independent component, but it is developed into smaller chunks and deployed on some of the cloud services where you don't physically don't maintain any service server as such. So the cloud services which you are using maintains the life cycle of that server, that is starting, stopping, then scaling, downscaling, upscaling of that server is maintained by cloud service and not by uh, you itself. That is kind of serverless architecture. That is on demand. Whenever you are hitting any website, at that time a server spins up, executes the application, then take your request, check if it is a database related request. If yes, then it connects the database and renders that database data on UI. So that is done on the request, and once that request is done, that server is again stopped. So let's say you're doing a world.com, you hit a request from your browser. That request goes to a serverless architecture. One server is pinned up at the backend, then that server serves your request and then stops execution. And that saves your overall cost of execution when you're using serverless architecture. Again, it depends on the kind of application which you're developing, which kind of architecture you should go with. If you process heavy data, then mostly we use microservices architecture. If we process light data, then we go with the serverless architecture, since it is a cost effective and it's a on demand service where you are not charged based on the day or month, but it is charged based on the request which you send and based on the execution time of that request itself, and not like, if I wanted to say an example, if I deploy my application on web, like google.com or facebook.com, I'm execute like I'm running my server 24 into 7 on the cloud. So I am getting charged for 24 into 7. That is for a month, and the plan is mostly a monthly or yearly plans. So even though if I'm using or not using any service of server where my microservice architecture are hosted, I'll need to pay the amount of monthly or yearly basis that I have subscribed to. But when I move to the serverless architecture, it is on-demand service. So the bill is again done on monthly basis, but it is not charged on the monthly basis, but it is charged as pay per use. So whenever my server is serving any request, that time my server spins up, and that the only the amount for that fraction of time is charged. So microservices, let's say if I am any of the cloud services costing me 1,000 rupees a day, then at the end of the month I will be paying 30,000 for a month for a microservices architecture. And if I go with the serverless architecture, let's say per request the billing against in a minute. Let's say for a minute I am getting charged 10 rupees. Then I know that my server works only for 5 hours. So roughly it comes into 600 rupees on daily basis. And if I do it in a monthly basis, then it comes into a 24,000. So I'm saving 6,000 when I'm going with a serverless architecture. So based on your request and your application requirement, you decide the application architecture which you are going to use. Again, there might be a cases where you are using a serverless architecture, but your requests are too frequent, due to which your serverless requests are served mostly throughout the day, that is 24 into 7. In this type of request, you will be charged more than a traditional microservice charges. That is, you might be charged more than what you might be paying for the microservices architecture. since you are using serverless architecture for 24/7. So this is one of the factor which we consider when considering the architecture of web application. So this is the microservices architecture where you have a single API gateway. This is a proxy layer where you don't want it to list or show your microservices API URLs or APIs to the clients. So these are the different kind of microservices. So consider each microservices as an functionality. That is, this can be considered as an authentication where you log in. So this can be a authentication microservice if you consider a bank application. Then consider this application as an accounts related details. So account customer detail service. So this is second service is customer detail service. Third service is a transactional service where your transaction happens, where some amount is getting debited or credited into your account. And hence going forward, this can be a multiple different kind of services. So we logically create a project based on our functionality and deploy it as a single application that is nothing but a microservices architecture. Again, the microservices architecture, mainly the principle which we follow is single microservices should perform a single operation or a single functionality. That is, a authentication server should perform only authentication. It should not it should not perform any request related to a customer account details management or transaction management. Then again, customer details management service should not perform any operation related to a transaction management. That is a thumb rule whenever we are defining the microservices architecture. And consider this as a physical server or a VM or a container individually. And this database again can be a single database or different database altogether based on your structure. Mostly in most of the cases, we have single database which is used by different microservices. But there might be cases where you don't want to expose your database to other services. In this type of request, we have different database for different microservices. Now comes into picture the serverless architecture, which I said. Again, this architecture is mainly considered or targeting to AWS cloud services, which we have listed in our previous slide. So we have listed some of the AWS Amazon cloud services services which we are using in this serverless architecture. So we have API gateway like we have in all of our normal or all of the different kind of architecture. This serves as a proxy layer. This gateway connects to a Lambda, and then Lambda connects to a database, gets the data, sends the data back to gateway, and gateway sends the data back to the client. So to develop serverless application, we use API gateway service of AWS, Lambda service, and database can be a DynamoDB or Aurora DB or a MySQL database or any other kind of database. So this is the Lambda is the function which gets spin up based on your request, and it shut down immediately once your request is served. Any questions till now? So what is scalability and what is scalable web servers? Scalability is nothing but, let's say you have one server where you are deploying your application, your website, and let's say that server can accommodate only 10 requests at a time. So 10 users accessing your website can serve, your server can serve that request. But let's say 11th user comes in and tries to access your website. Since your server is not capable of serving 11 users at a time, this request will not be served and this will fail. So how we handle this kind of things in backend? So that is called a scalability. That is scaling horizontally, vertically, or diagonally. This are the different kind of scaling types. So scaling can be done like in an increasing or decreasing way. That is upgrading or downgrading way. So same example, your server can serve 10 requests, but at a time only 3 users are using your request, and in future as well, not more than 3 or 4 users will be using your website. So at that time, you can downgrade your server and save some cost. So mostly scalability is for help us to perform two days, that is high availability and cost management. To perform this kind of to save on this kind of things, we mainly have different kind of scaling solutions. One is vertical scaling. So what is vertical scaling is downgrading your configurations or upgrading your configurations. So if I take an example of your laptop where you're using, so vertical scaling can be considered as you have a 512 GB hard disk and 58 GB RAM. So when you are vertically upgrading your scaling your laptop, you will be moving from 8 GB RAM to 16 GB RAM, 512 GB hard disk to a 1 TB hard disk. That is called a vertical scaling. That is, you have single laptop, but you are upgrading in hardware. Then we have horizontal scaling. So horizontal scaling is nothing but increasing your laptops. So your one server can serve 10 requests. So you will be adding multiple servers. That is, when you add 3 servers, now you will be able to serve 30 requests at a time. So when you are having 4 servers, it will be 40. Or you will be like this kind of scaling is called horizontal scaling. Then we have diagonal scaling. Diagonal scaling is nothing but a combination of vertical and horizontal scaling, where you are upgrading or downgrading your configuration as well as increasing and decreasing your number of servers. That is called an horizontal scaling. Any questions?
Hmm.
So these are the technologies used to develop a web application altogether. And whenever you might be hearing a full stack developer or full stack keyword of web development, most of these technologies comes into picture. So like I said, HTML, CSS, and JavaScript are the languages. These are must have. Then there might be a React JS or Angular JS for front end. Backend can be a Python, can be a Java, can be a PHP, Ruby, or Django. Any one of these, not all. There might be a large scale application where different kind of technologies comes into picture, but mostly when full stack developer comes into picture, these three are mandatory: HTML, CSS, JavaScript. Any one of this, React or Angular. Then at backend, any one of the backend server are required, and any one of the database services are required. That can be a MySQL, Mongo, Postgres, Oracle, Firebase, Cassandra, and different kind of technology. And to develop a web application, we use different kind of tools. That is, VS Code is a uh, your web application development tool, which is used to develop your front end and back end. Then we have Git to maintain our code base on server so that multiple people can collaborate together. This can be a Git or a GitHub in any ways, which is used to maintain your repositories. And repositories is nothing but your code base where you store your code base. Is called a repository. And GitHub is one of the repository. Bitbucket is one. Then we have GitLabs and many other repository services. You can go search this on Google and sign up. and create a free account for a GitHub repository and start committing your code or pushing your code to a GitHub repository. You'll be able to understand how GitHub works. All your code, all your changes, when you're working with different teams, different people on different technology, we collaborate using GitHub. And the technology which is used is GitHub. That's it. I have any questions throughout the slides or out of slide? Any questions anyone has around anything? If not, then thank you for listening me and going through all the slides calmly. Hope you might have got some inputs of how industry works and how a web application development works and what are things comes into picture when you talk about a web application. That's what I had for today. Thank you.
Thank you, Mr. Amit.
Thank you, sir.
So, on behalf of PCET, Pimpri Chinchwad University, it is my privilege to give a vote of thanks. So, I thank Mr. Amit for sparing his valuable inputs and his valuable time. He has highlighted the role of web application architecture. He has also explained in detail about the components and what is the role of the API while designing any web applications. So, on behalf of entire group, it I would like to invite you to our campus someday because so it's far away. So not today. So in the maybe in 1 or 2 weeks, I will request you that you please visit the campus and we are going to organize this one-day workshop on the web applications where the hands-on is supposed to be done from the students itself.
Sure, sir.
Okay, thank you, Amit.
Thank you.